And this is the first of those case studies. So the concentration is called mathematics education, and students in this concentration have a very challenging task, and it is that these students, unlike the other three concentrations, these students are required to clear upper level classes in mathematics, in particular algebra and analysis, which are probably some of the most difficult classes in our entire major. These students have the challenge to clear these classes before year 4. Okay? In their last year in college, these students cannot be taking upper level math classes. They have to be taking, they have to fulfill all requirements in their education, some more education requirements. So that means that there is a plan here, at least a plan, a pencil plan, a theoretical plan, for these students to take 2 classes, mathematical reasoning and differential equations during the summer. So the way you see this is semester 1, this is really fall, spring, summer, fall, spring, summer. And so the idea of this plan is to take mathematical reasoning in this summer, because in the spring of the following year, they're going to take 2 classes that have math reasoning as a prerequisite, and then differential equations is planned here for another summer, because immediately after that summer, there is a plan of taking a class, math modeling, that has DFQ, differential equations, as a prerequisite. Now, the issue is that what we're seeing here in this graph is the enrollment in both of these classes. Mathematical reasoning is on the vertical axis displayed on the right side, and in red, appears here in red. So from summer 2012 through summer 2018, so we can see here that maybe 4 out of 7 summers, mathematical reasoning has had 0 students. That means the class was canceled for those summers. Other summers in which a class was not canceled, so in summer of 2016, there were 2 students. And so basically, reasoning during the summer oscillates with between 2 and 8 students. I'm looking at the right side vertical axis here. Now in blue, we see the enrollment in the summer of differential equations. Differential equations hasn't been canceled as many times as math reasoning. However, we see 3 consecutive summers where there is kind of a decreasing trend. And so the thing that this is related to is that at ETSU, so the theoretical plan is that for this population of mathematics education students, those 2 classes in the summer are key for them to complete the program in 4 years, right? Somehow, some of these classes are not really making. This is the notion of the class makes or doesn't make in the summer, and that is compounded or tied in already with the school and the entire undergraduate population facing that statistics that our undergrad students take more than 4 years to graduate, 5, 6, or 7, right? So if we look at the number of graduates, the production of Bachelor of Science degrees, this is the same data, but look at it in a slightly different way. Now the colors denote the year, and then if you look at this bunch here, is the graduates with the concentration mathematics education. So in color green and purple, we have the graduates in 2016, 2017 in green, and purple in 2017, 2018. Those are good numbers. So those are 8 in 2016, 17, and 7 in the spring of this year. So 8 and 7. Prior to that, the previous 2 years, there were as many as 2 and as many as 3. So remember, this is graduating, at all times, we're graduating almost a quarter of the size of students that we have in our undergrad program. I think any student that graduates is a super big, huge accomplishment. But graduating 8 or 10 students would be a good goal. But I think part of what we also need to keep in mind is, okay, so we graduated 7 students the last time, but how long did it take them to graduate? I think that's something that needs to be part of the benchmark of the goal, because we're graduating 8 or 10, but they're taking 6 years. Maybe it'll be better to graduate 8 or 10 if they can graduate in 4 years, So
if we're graduating a quarter rather than it sounds like 4 years. We graduate 1 quarter this year and 1 quarter next year and 1 quarter next year, and then they're all graduated. Not necessarily.
Yeah, so that's the way I used to think also, right? Part of the reason why we have this decline is we're not recruiting. The number of departures, the graduates, is not being replaced sufficiently with the new arrivals. So our recruitment, the number of new majors, it's kind of being outcompete. It's happening too slow in comparison to the students that are either completing or just dropping out of school, you know. So, yeah, you're going to say something?
Do you have any data about whether the decline is due to fewer students coming in or more students flunking out or leaving for another reason?
I don't have that with me in these case studies, but that's exactly the type of questions that I think we need to be, that merits further review and further investigations. Causes. What are the causes of losing this? I mean, if we lose one student, even if we're losing 1% of our majors, I think that merits review. But when we're losing 8, 19%, 15%, I think this is an issue. These are difficult times, these are problems. And one of the first things is identify the extent of the problem and then identify potential causes to then devise a plan for, we need to reverse this. We need to increase the number of majors, you know, but I am with you. These questions, we need more questions like this, and we need answers or potential answers or the answers should lie between here and here, something like that. Yeah.
In the Johnson City Press a few days ago, they said that the East Tennessee and Southwest Virginia district was the number 4 district that was good for teachers in the entire United States. Now, that's a good recruiting tool if we can get that word out.
I think that would be a good recruiting tool, provided that this math education undergrads could finish in 4 years. You know, and if we were to accomplish such thing, because look, I'm using this as a case study. I am not certain, but I suspect that this challenge that is reflected in this program of study here, this is to fulfill state requirements. The state of Tennessee requires these students that in their last fall and spring, they're not taking upper level mathematics classes because they have to take residence, student teaching, and residence instructional technology. So there are certain education requirements that are upper level that are reserved for the last 2 semesters. And so these are state guidelines. If our undergraduate program manages to produce, we're like a factory producing professionals, and if we can produce these professionals so that they finish in 4 years, what I'm saying is I think the math education students are facing this type of problem across the state. I wouldn't be surprised if they also face a similar problem of taking too long to graduate in another state university in Tennessee.
Well, you just said helps explain why there are more people taking third-year courses than fourth-year courses, because the people who would be taking fourth-year courses are taking the education courses.
Yeah. So that right. Yeah, or even in this plan where DFIQ is 2,000, but there is a 3,000 level class, which is a prerequisite of everything in this upper level. So even in this plan, when you move that to the summer, I mean, according to this plan, you'd like to have 5 or 10 or 20 students on that math reasoning class that summer. However, you're having between 2 and 8